So in 1.2, we are looking at exponents and radicals. If you haven't already, will you guys just take a moment and will you read down everything that we are going to be learning about today? Okay, so we're going to focus today a lot on radical expressions, rational expressions, and then simplifying with exponents. There's a little bit of scientific notation, and then some rationalizing the denominator. So again, all things that you did last year in Algebra 2H or in your college algebra course. So the first thing we're going to talk about is exponential notation. If a is any real number and n is a positive integer, then the nth power of a is, and I put this in a special box because in your book they're going to have these information boxes, and so I like to have us talk our way through those. So a to any power just means you are multiplying a that many times. So it's a times a dot 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 as many times as your exponent. So we say there are n factors. And in this case, a is called the base, and we know that n is called the exponent. Okay, so all of that is review. These are terms I'll be using, so we have to make sure we're good with the vocabulary. So what's the difference between negative 3 to the fourth and negative 3 to the fourth? Explain. So if you have the negative inside parentheses, that means you are multiplying negative 3 4 times. Okay, and yes, we'll be doing this without a calculator, and I'll be showing you strategies for doing that. Right? So if you don't know what negative 3 to the fourth is off the top of your head, that's okay. You know what negative 3 times negative 3 is, right? I said, right? Yeah, 9. And we know 9 times 9 is 81, okay? All right, and then if you have the negative on the outside, if you have negative 3 to the fourth, that means that you do negative and 3 times 3 times 3 times 3. The negative is on the outside. Okay, so you would get negative 81 here. Okay, so if the negative is in the parentheses, you're going to multiply negative 3 if you have a negative inside. I just put that in there instead of words, but if it's inside the parentheses. Okay, and then if the negative is not in the parentheses, negative stays in front. Okay, and this is a very common mistake, especially when people are using calculators, because they'll forget to put it inside parentheses and they'll just take the negative 81. So we have to know the difference without our calculator. Okay, and then now we're going to talk about zero and negative exponents. Anything to the 0 power is equal to what? 1. Great. Do you guys remember what to do if the exponent is negative? Make it a fraction, put what on top? 1, and then this becomes positive. Okay, so the exponent becomes positive, and you're going to make it a fraction over 1. Okay, so explain in words how you're going to make that positive. So this is called the reciprocal. So you can either say use the reciprocal, you can say put it over 1, and change the exponent to a positive. Okay, and then I want you to think about this. So if a negative exponent is in the bottom of a fraction in the denominator, how would you make that positive? And see if you can write out your explanation for that. If you have a negative in the denominator, if you need to think of an example. Okay, give me a thumbs up if you're feeling confident that you know how to do it. Okay, so if you had a negative exponent in the denominator, in order to make it positive, you would move it to the top. So if you had something like this, if you had 1 over a to the negative n and it was on the bottom, okay, this would be the same thing as a to the nth power because you'd move it to the top. Okay, so if the negative exponent was in the denominator, move the term to the numerator and change exponent to a positive. All right, so I understand some of you are feeling a little rusty. It's been a while, so why don't we do a few examples together? Okay, so we have x squared, x to the negative 6. So there's a couple ways you can do that. Do you guys remember your exponent rules? If they're being multiplied together, what you do to the exponents? You're going to add them together. So 2 plus negative 6 is negative 4. So you never, ever want to have a negative exponent in your final answer. So if we want to make that positive, we just have to put it over 1. So 1 over x to the 4th, this would be your final answer. Okay, and then let's try this one. So if I have x to the 4th, y to the negative 6, z to the negative 5th. And again, if you feel like that's something you can do without me, please go ahead and do that. Okay, so when I taught this last year, what I usually say that helps me is if it's positive, it can stay. If it's negative, it's got to go. So if it's positive, it stays. If it's negative, it goes. So if I'm doing that, I just work my way. I start with this positive exponent. It's going to stay. So it's going to stay on the top. Negative, we don't want anything negative. It's got to go. So it's going to move to the bottom and become positive. This is negative and on the bottom, so it's going to move to the top. And that would be your final answer. You don't have to combine any of them because they're all different variables. I'll get them. I'll grab it for you. All right, I want you guys to think about this. Now, there are multiple ways to do this one. And it's fine if you just want to think about what the different ways are, that's okay. Oh, and so it's in parentheses you have okay, so in parentheses you have y and then it's over x to the negative 2 and then everything is raised to the power of negative 3. Do you guys have any ideas of what you want to do? Okay, yep, so you can move the negative exponent to the top first. What else do you think? Okay, you can also distribute the -3 to each one and then move around the negatives. Okay, or there's one more way. Any of those ways are fine, but if you have a negative, you can, and you have a fraction, you can just flip the fraction and make it positive. Okay, so if you do that, you can do x to the -2 and y, so you just flip it and make it positive. Oh, thank you. Okay, so you flip that and you can make it positive and then you can distribute. It honestly does not matter which one you do. It's just there are some of them where that's going to be helpful. So then you'd have x to the -6 over y cubed. And then of course we cannot keep any negative exponents. So if it's a negative, it's got to go. It's got to move. So a negative on the top means you're going to move it to the bottom. Oh, but this is on the bottom. So what do I put on top? 1. Great. Okay, so with these, there are so many different ways you can do it. And honestly, if I were doing it, I probably would just do y to the -3 over x to the 6. And then I would move it down and it would be x to the 6, y to the 3rd. Okay, so you're going to have to find what works best for you. And by that, I mean which way you find that you make the less mistakes with. Okay, because I know our brains work in different ways, and so I want you to do what's best. Okay? All right. So the laws of exponents. Again, we're going to go over these very quickly because this is the 3rd time you should be seeing these, right? In Algebra 1 and Algebra 2, now again here. So when you are multiplying, you are going to add the exponents together. When you're multiplying with the same base, you're going to add the exponents. Okay, and then if you're dividing, you're going to do what with the exponents? Subtract. Okay, now this is when you have a power to a power. When you have a power to a power, that's when you multiply. So it would be a to the n times n. And then if you have a and b both inside parentheses, it's a to the nth times b to the nth. So you distribute that power. You have to raise both to a power. Now, people sometimes forget to do that when a is actually a number because we just get used to distributing to the variables. So that's something that you'll want to watch out for. And then if you have a fraction, you have to make sure you apply it to the numerator and the denominator. Okay, and then this is one that we just talked about, right? So if it's to the -n, use the reciprocal and then make it positive. Okay, they said invert the fraction. That's just the reciprocal. Okay, and then this is what we just practiced. So if you have a to the -n in the numerator, to make it positive, it goes to the denominator, and then b to the m will go in the numerator. Okay, so when you're simplifying an expression, like I said, you're going to have several different ways that you can do this. Okay, so I'm going to let you think about this and give it a try. Okay, so think about how you want to do that. Okay, so you do have variables in the numerator and denominator. You also have numbers that you need to simplify. So you can decide if you want to move the negatives or if you want to do the subtraction. Okay, and that is honestly up to you, and you're going to have to figure out what works the best for you. I like to just go in order, numerical order. So 8 over 2. What's 8 divided by 2? 4. So because it's that whole number that goes on the top. Another way I remember where it goes is I look for the bigger number. So what's bigger, 8 or 2? 8. So it has to go on the top. 8's bigger. 4 is going to go on the top. Same thing with these. 3 or negative 5. What's larger? The 3. So the A's end up on the top. So there's two ways you can think about it. You can think of it as 3 minus negative 5. What's 3 minus negative 5? 8. So if you had 3 minus negative 5, remember it's plus. So 8 to the 8th, that's positive, right? If it's positive, it's going to go on top. If you're doing the B's, you have negative 4 minus 5, which is negative 9. So if you have b to the negative 9, in order to make it a positive, it goes in the denominator. Now again, if you were to analyze these, 5 is bigger, so you know the b's end up there. You can also think of it as, oh, if I were to move it and do the positive and the negatives, I'd have a cubed, a to the 5th. I'd have b to the 5th and b to the 4th if I moved them, and then I would just add 8 and 9, and they'd be in their respective places. Okay, so you get to decide what you want to do with that. All right, and then, nope, because we're always going to make it positive, so you would always want to change it. All right, and then the next one is 3z, the quantity 3z squared, and then the quantity 6z to the second, all raised to the power of negative 3. Okay, so why don't you start by simplifying this first one, and then you can think about how you want to tackle the second one. Okay, so we should have the 9z squared here once you distribute. You don't have to have that in parentheses. I just do that by habit because I know I'm going to multiply. And then what I would do is I would want this to be a positive. So I'm going to make 1 over 6z squared to the 3rd power. Okay, and some of you might be able to do that all in one step. I'm just going to do it step by step for this. Okay, now remember we're doing this without a calculator, so I'm going to show you some tricks to make that a little bit easier. Okay, because not a lot of us probably know what 6 to the 3rd is off the top of my head. I really don't. And so I'm just going to distribute it. So I have 9z squared, and then this would be 1 over 6 to the 3rd times z to the, a power, you multiply z to the 6th. Now remember, when you are multiplying a fraction and a whole number, the 9z squared is getting multiplied by what over here? Just the 1. So 9z squared is on the top, 6 cubed times z to the 6. Okay, and I'm just going to show you the shortcut way to do this afterwards, just to help you think about numbers. And it's going to feel like a lot because we've just been on break and haven't been multiplying things in our head for a while. But 6 to the third power is the same thing as 6 squared times 6. And we know 6 to the second is what? 36. So if we do 36 times 6, carry the 3, 18 plus 3, 216. So you have 9z squared over 216z to the 6. And then we'd have to reduce this, right? So if you were reducing that, you could see if 9 goes into 216 evenly. You could also see if 3 goes in there and do 2 reductions. Do you guys remember how to tell if 3 goes into something by looking at it? You can add the digits. So 2 plus 1 plus 6 is 9. So you know that 3 goes in there. So if you wanted to, you can. You could also guess and check with 9. But if you divide 216 by 3, 3 goes into 21 how many times? 7. And 3 goes into 6 how many times? 72. So if I divide by 3, this would be 3 and 72. But doesn't 3 also go into 72? How many times? 24. So it would be 1 over 24. Yep, but you would divide them each by 3. So 3 divided by 3 is 1. 72 divided by 3 is 24. And then let's do the z's. So if you have z squared on top and z to the 6 on the bottom, do you guys know how many z's you have and where they go? On the bottom, yep, z to the 4. Yep. So that would be your final answer. Okay, and really that's not too bad, but another way you could think about it, and I'm going to show you this way so you can start thinking about powers. 9 can be written as 3 to the second power, right? And then if you have 6, isn't 6 just 2 times 3? Okay, so if I wrote this as 2 times 3 to the third, and again, I want to show you how to do this using your exponents. So if you did that, this would be 2 to the third times 3 to the third according to our powers. And I'm just going to line these up so I can simplify. If this is 3 squared and this is 3 to the third, what would be left? 3 on the bottom, right? So look, 3 squared would cancel out with this, and it would be just 3 to the first, or 3. What's 2 to the third? 8. What's 8 times 3? And again, you would get 24. Okay, so again, it doesn't matter to me what way you think about this. This is more like of a higher order, using your rules. This is the type of stuff that can help you with SAT type prep, just thinking in some different ways. Okay, but either way is going to be fine for that. All right, we're going to do one more example together. So 4y cubed, oh, thanks. Some things never change, do they? Okay, and then that is over x to the 1/2. I know they're fractions, don't be scared. We can do it. And then we're going to multiply it by x to the -3, y to the 6, 8z to the 4, all to the 1/3. Getting crazy up in here. If you don't have room and you want to put yours just on a separate sheet of paper, you can. Okay, so when you have something like this, where there's so much going on, you need to break it down into manageable steps. So what do we think is a first good step for this? Okay, so you would, if there was division, you would. So what I would do first is I would get rid of these exponents by distributing them. Okay, and like, let's just work with the first one. So if you do this, 4 to the second is 16. And then are we multiplying or adding? Power to a power. Yep, you'll only add if you see like 2 y's in there. So 16y to the 6. And again, when you're multiplying a fraction by a whole number, you only have to multiply the whole number by what part? The top. So 2 times 2 is 4. So this is just z to the 4/3. Okay, and then on the bottom, 1/2 times 2 is just what? 1. So just x. Half of 2 is 1. X to the first, just x. Okay, and then we're going to do the same thing here. So we're going to simplify. I'm not even going to worry about moving the negatives because I'm somebody, I know if I just go step by step, I'm not going to make any mistakes. If you feel comfortable doing 2 things at once, like multiplying and moving, go ahead and do that. So what I would do is just worry about distributing, and I would say, okay, what's 3 divided by 3? 1. So this is just -1. So 6 times 1/3 is just 6 divided by 3, so that's going to be 2. Now, 8 to the 1/3, if you want to write that out, you can. Do we remember from last year that if you do 8 to the 1/3, it's the same thing as the what? It's the same thing as the cube root of 8. And what's the cube root of 8? 2. So I'm just going to put 2 there. And then again, look at how nice this is going to be. 4 times 1, so this is z to the 4/3. And why is that nice? They're going to cancel. What's z to the 4/3 divided by itself? Just 1. Okay, so those are going to divide out. Now, because those are the same, I got rid of that. Otherwise, I would just go straight across because I like to organize mine alphabetically. So I have 16. Okay, I have the y, but I'm going to put the x first because I want to line them up in alphabetical order. That's just easier for my brain to process. And then I have y to the second. So I have y to the 6, y to the second, x to the -1. I could also change that right away to 8. Just depends on what you want to do. Okay, and then 6. That does look better, right? Okay, and then 16 divided by 2 is 8, and then 16's on top, 8 goes on the top. If it's a negative, it's going to move. So I have x to the -1. If I put that on the bottom, how many x's are now on the bottom? 2, so it'll be x squared. And then we already talked about we have y to the 8th. Okay, so this is going to be your final answer. I know, so I feel like it started off like this seemed like a lot of chaos, right? But you just break it down, you do 1 step at a time. Okay, and you know the rules, you just got to apply them one by one. All right, now we're going to talk about scientific notation. So if you have a positive number x in scientific notation, there are a couple rules that have to happen. They define it as x equals, and then a is the value times 10 to the nth power. And then do you guys remember what the rule is for this number in front for a? It has to be, there's some stipulations. It has to be between, not 0, but 1. Good, between 1 and 10. So it has to be at least 1 So 1 is less than or equal to A, and that is less than 10. And then you'll also see this, it says n is an integer. Okay, so n can be a positive or a negative whole number. And again, this is in an information box in your textbook. Okay, the main thing I want you to remember about this is how this is going to end up looking on your calculator, because when we use that, we have to look out and make sure we remember what the symbol is. Do you guys remember that? Because it doesn't show it like this. It uses a letter. E. Yep. So e to the negative 6 is what that would look like. Okay. And then we're going to talk a little bit about radicals today. And I know it says to look in your book, but I'm going to help you fill it in. So fill in the box with the information in your blue box on page 17. What does b is greater than or equal to 0? Or why does b have to be greater than or equal to 0 for this case? So when you are doing your radicals, they will tell you that the square root of a is equal to b. And that means that b squared equals a. And b is greater than or equal to 0. So let's talk about how we get from here to here. What would you do to both sides if you wanted to undo this radical? Yeah, you would square both sides. So if you squared this side, it would undo the square root. And if you squared b, you'd have b squared. Okay, now they say that b has to be greater than or equal to 0, and that's because of this. If you are taking the square root, okay, of a value, you know it has to be a positive number. Okay, and the square root of a positive value is equal to a positive value. So the square root of a positive value a has to equal a positive value. We're going to talk about when it's plus or minus and when there is what's called a principal root. So that square root symbol, that means the positive square root of whatever variable you have. I'm just going to put of dot, dot, dot. So whatever you have underneath there. Okay? So while it's true that if you have the number of 9, it does have 2 square roots, the positive and negative 3. If the notation is the square root of 9, that is reserved for the positive square root. And sometimes this is what's called the principal square root. And if we want the negative root, we have to write the negative in front like this. Now, in previous math classes, you've had to put plus or minus. Do you guys know when you put the plus or minus? It's when you are solving for it. So if you have this, x squared equals 9. If they gave you x squared and you are the one taking the radical, see how the radical's written out here? The radical's written out here. Is there any radical here? No. You would have to use it to solve. So if you were using it to solve, then yeah, it would have to be plus or minus because you don't know which one X is. They both make that statement true. Okay, so when do we include that? When you're solving for a variable or an unknown. So that's when you put the plus or minus, if you are actually solving for that variable. Okay, so when you have an nth root of any positive integer, you write it as the nth root of a. That's going to equal some value b. And this means b to the power of n would be equal to a. So the cube root of 8 is 2 because 2 to the third is 8. The stipulation is whenever you have an even root, if n is even, a has to be greater than or equal to 0, and b has to be greater than or equal to 0. If it's odd, it doesn't matter. Okay, if it's odd, you can have an odd number of negatives that multiply to a negative. Okay, but if n is even, you have to have them be positive, because think about what happens when you multiply an even number of negatives. If you multiply 2 negatives, it ends up being what value? Positive. If you multiply 6 negatives, it's positive. Whenever you multiply an even number of negatives, it's going to be positive. Okay, so you can only take even roots of positive values because an even number of factors always result in a positive value. So you can only take even roots of positive values because an even number of factors always results in a positive value. Okay, so a negative times a negative is a positive. Thanks. And then a positive times a positive is a positive. That's what this means. And that's why it's not true for odds, because a negative times a negative times a negative, that is a negative. A positive times a positive, that is a positive. So that's why they're allowed to have both signs. Okay, so we're going to pause here for today. And I'm going to give you some time to work on